All right, 2.4, factoring complex trinomials. When we're factoring complex trinomials, it's going to be important to follow a certain set of instructions. In this video, I'm going to show you two different ways of factoring. One, I like to dub as the OI check, and we'll see why that's called an OI in a minute. And the other way is factoring by decomposition. All right, factor the following. So here's some examples of questions I'd like you to factor. Now, first thing you should notice is that, like in the last lesson, we talked about where there's a number in the front and we try and common factor it. And we can see here, just even in this first example, that 3 cannot be taken out of everything here. So, what we need to do now is improve on our types of factoring. This is known as complex trinomial because you have a number in the front. But really, the process is very similar to what we looked at earlier. And that is, the product here is going to be the first and the last multiplied. So we multiply these two. And what is the product? The product is, that's right, 24. Okay? So the product is 3 times 8, which is 24. The multiply of the front number and the last number. The sum is going to be still that middle term, which is 14. So we need to find out what two numbers multiply to give us 24 and add to give us 14. So we can figure out that they must be 12 and 2. So essentially what we need to do is get 12 and 2. So we're going to literally get a number on the outside and a number on the inside. One of the numbers is going to be 12 and the other number is going to be 2. We want both of them to be positive. So now we need to find out how we're going to break up 3x squared and 8 to get 12 and 2. So 3x squared can be broken up into two parts, 3x and x. We know that much because it's the only way we can break up 3x squared. We know that 3x times x will give us 3x squared. We have to break up 8 later on to put these numbers over here, but we need to somehow get positive 12, don't forget. So we have to put the breakup of 8 into a special place. That is, we want positive 12. So 3x times what gives us positive 12? Remember, we need a positive 12. Well, that is plus 4. 3x plus 4 gives us positive 12. And x times plus 2 gives us plus 2x. How does that help us? Well, 3x times 4 is 12x, plus 2x gives us 14x. And 2 times 4 gives us 8. That's the last part. So our OI, our middle part of FOIL, our outside, inside, will match the middle number when you add them together. All right, again, we multiply across and then we add the outside and the inside. We multiply the outsides, multiply the insides, then we add it together. Let's look at another example. All right, ready? Now, a lot of you may not be comfortable doing it this way. This is the fast way to do it. What we're going to look at is another example now. We're going to see how to factor this with the OI, without the OI, but with something called decomposition. Decomposition is the breakup. So we're unfoiling the question. So basically we're getting the question that's just before this, before we collected the like terms when we foiled it. So that is, we need to break up 14x into two pieces. What two pieces? We're going to break them up into 12 and 2, the two numbers that we found. 12x plus 2x will give us 14x, and 12x times 2x will give us that 24x squared, which is what we have here on the outside. Finally, we have the plus 8 here, and what we're going to do in this next step is we're going to take each piece of this So again, the 14x came from the 12x and the 2x. And now what we're going to do is take the first half of what we broke up and the second half of what we broke up and common factor within there. So basically, if I was to cover these two up right here, if I was to cover that up, I need to, ignoring the piece, just looking at the red, 3x squared plus 12x, what I want to do here is common factor. How am I going to common factor? Well, what number can I take out of 3x squared and 12x? Yes, that's right, 3x can be taken out. What's left when we take out 3x? Well, we're going to be left with an x plus a 4. We're left with x plus 4. Then from this section, what am I going to take out? I'm going to take out a plus 2. And what are we left with when I take out the plus 2? X plus 4. That's right. So from each piece, I'm going to take out the 3x from the red piece, 2 from this purple piece, and I'm left with this. What do we have here? Well, what we have is, oh yes, do you see what I see? Yeah, I hope so. You see that both of these has an x plus 4. So I can take out that x plus 4, and then what's left? So remember, we're taking out the x plus 4. We're taking out this x plus 4. What are we left with when we take out these brackets? Yep, that's right. We're left with 3x plus 2. Oops, that's too much there, folks. Just a minute. Give me a second to go backwards. Here we go. So the idea here is that now what we've reached is we've reached the final statement. And remember, that we just did it by the OI way, and we saw that we got the exact same answers. The difference between decomposition and the OI check is literally the number of lines it takes to get there. So let's try the next example using the OI. All right? So product is, hopefully you see it, -4. And the sum is -3. What two numbers multiply to give you? -4 and add to give you -3? That's right. -4 and +1. So we set it up. Double set of brackets. We want -4. But you see we have 4x squared and -1 to deal with here. So we have 4x and x. The reason I want those is so that I can get a -4. The way I can get a -4 is take the outside numbers and multiply that to give us -4 by 4x times -1. And the inside number is going to be +1. So again, what we have here is the outside numbers is -4. Our inside number is -1. Or sorry, +1, and that gives us the answer that we're looking for. We can check by multiplying. 4x times x is 4x squared, 4x times -1, and x times +1. When we add that together, gives us -3x. That's our OI. And our last numbers is +1 and -1 give us -1 over here. So again, we're using OI to do this. There's also decomposition, so let's look at the decomposition question. Ready, folks? Here we go. Okay, here we go. Break up 4x squared, break up the -3x into two pieces. They are -4x plus x minus 1, so those are the numbers that we found over here. Now, we break it into two pieces. We common factor the green piece first. We get 4x. Break it up, you get x minus 1. And then in the second piece, the purple piece, I add 1 and take it out. And what do we have left? We're left with x minus 1. There we go. And then when we do that, what do we do next? Well, we have x minus 1. And in brackets, the next piece, 4x plus 1. So what we have here is x minus 1 times 4x plus 1, and this is the final statement. That was exactly the same answers we had in the OI way, or you can use decomposition to factor. All right, moving forwards. Let's look at the next example. We're going to use just the OI method to factor this. The more often we use OI, the faster we'll get to our answer, folks. So we're just going to use OI this time. I'm sure you can do decomposition if you needed to. Here we go. What two numbers? What's our product? Our product is positive 6, and our sum is negative 5. So we need to find out what two numbers multiply to give us positive 6 and add to give us negative 5. That is negative 3 and negative 2. So how are we going to do this? We need to get negative 3 and negative 2 from these numbers here on the outside. Well, 3x squared can only be broken up into 3x and x. So we have our outside, which will be our negative 3. Okay, remember that's going to be our negative 3. It doesn't have to be necessarily that one, but in our case we're looking at outside being negative 3. So 3x times, that's right, negative 1 will give us negative 3, and our inside is going to be negative 2 is what we're looking for. So we have x times negative 2 to give us our values. Let's check these answers. 3x times negative 1 is negative 3x. X times negative 2 is negative 2x. Negative 3x plus negative 2x is going to give you negative 5x. 3x times x will give us 3x squared. And negative 2 times negative 1 will give us positive 2. So when we FOIL this out, it will give us the answer. And that's the way to check your answer. All right, one more. Let's look at the last one. Oh, you should notice that right away there's something there that we could do to this question that could make things a little bit simpler. That's right, we need to look for a common factor. So if you look carefully, there's a number that's in here that I can take out of everything. That's right, 2. Take out the 2, you get 6m squared minus 5m minus 4. And what do you do next? Is we will factor this like we would normally. So take out the 2, leave the 2 on the outside, and we will do that in a second once we figure out the product. What's the product? Product is 6 and negative 4, which makes negative 24. The sum is going to be negative 5. That's the middle number. So what two numbers multiply to give us negative 24 and add to give us negative 5? All right, so negative 8 and positive 3 are the numbers. So break it up, leave the 2 on the outside, folks, just leave them there. This 2 just carries it down. And now we want to find combinations to give us negative 8 and positive 3. Remember that the outside, we need a number to be negative 8, and the inside is going to be positive 3. How am I going to get that, given that my front number is 6m squared and my last number is negative 4? Well, to get this negative 8, I need 2m from the front and negative 4 at the back. 2m times negative 4 gives us negative 8m, which is what I want here, negative 8. And then my other number, well, 2m, and what? Let's see, that should be 3m. Why should it be 3m? Because 2m times 3m gives you 6m squared. So we have 2m times 3m, which gives us 6m squared. And we want the OI part, the inner part, to be positive 3. So I should have a positive 1 multiplied by 3m to give us positive 3. How does that help us? Well, 2m times negative 4 is negative 8m. 3m times 1 is positive 3m. Negative 8m plus 3m gives you negative 5m. And positive 1 times negative 4 gives us negative 4. So we've checked out, everything works, and this is your final answer, folks. Okay, so just some general information. In general, if the quadratic expression ax squared plus bx plus c, where a cannot equal 1, can be factored, then the factors of the form px plus r times qx plus s, where p and q equal a, r times s equals c, and ps plus rq equals b. So it's just what I was talking about with decomposition and how to get there. Now we did some decomposition, and now we're going to use that trial and error or that OI check that we were doing. We've done some OI already, and we're going to keep practicing some OI some more here. So here are 2 more examples I want you to work through. So given these 2 examples, let's try and factor these. The first one, is there a common factor? No, there isn't. So find the product and the sum. The product is going to be negative 30, and the sum is going to be positive 13. So we need to know what numbers multiply to give you negative 30 and add to give you positive 13. Now some people might be thinking already 3 and 10. Remember that we want the sum to be positive, so it's positive 3 and positive 10. But look, when I multiply those numbers, that does not give me negative 30. So folks, unfortunately, although this looked like it was the right answer, it isn't in our case. What does work is positive 15 and negative 2. Positive 15 and negative 2 adds to give us 13 and multiplies to give us negative 30. All right, on that note, what we'll do is do the OI. So the inside will be positive 15, the outside, will be positive 15, and the insides will be negative 2. How am I going to get positive 15 with 3x squared and minus 10? Well, we're going to take 3x from the front and positive 5 from the back. So 3x and positive 5 gives us positive 15, and negative 2 times x gives us negative 2. And when I add the OIs, so OI outside is 15x plus negative 2x, that gives us 13x. And when I multiply those, I get 30x squared, negative 30x squared. And what else I get is when you take the first times the first, it's 3x squared. Last times the last, that gives us negative 10. So everything works out, folks. All right, what I'm going to ask you to do is stop the video now and try B. Once you're done, restart the video. Okay, stop your video now. Hi, you're back. Great. Let's look at the last one. We know there's no common factor, but we also know that the product here is going to be a little bit harder because it's a bigger number, but it's not to be afraid of it. We have positive 120 is our number, product, and our sum is going to be negative 43. So our product is 120, our sum is negative 43. What 2 numbers multiply to give us positive 120 and add to give you negative 43? Well, that is, here we go. We want to break it up and we want to try it out. So we're going to try 1 and 120. Does that work? Nope. 2 and 60. Does that work? Nope. 3 and 40. Does that work? Well, yep, folks, that does work. Negative 3 and negative 40 gives us negative 43. And negative 3 and negative 40 multiplied gives you positive 120. So we want negative 3 and negative 40 from these numbers here, 8 and 15. So our outside is going to be our negative 40. Our inside is going to be negative 3. So our outside number, so we need to get these numbers, and they are negative 40. So I'm going to take 8m from here, and I'm going to take 5 from this one. Okay, 8m and 5. 8m and minus 5 gives us minus 40. And then I'm going to take the 1m from here and the 3m from here, negative 3, and make that negative 3m here. And that's our negative 3m, our negative 40m, that gives us negative 43m. And then when I multiply them, I'll get these values as well. All right, folks, so that's the end of the video. That's the end of complex trinomial factoring. Good luck. Have a numerical day.